Hello and welcome to my channel, Boo Snakes and More. Today we're going to be talking about the Earth's core, so let's dive into this video. And please like this video and subscribe to the channel. And for more videos like this, also watch my other house channel, A&A Snakes and Stuff. My youngest son's channel, He Needs Toys and Games. Or my oldest son's channel, Little Chris 10. Now let's dive into the video. Deep inside Earth is a solid metal ball that rotates independently of our spinning planet, like a top whirling around inside a bigger top. Shrouded in mystery, this inner core has intrigued researchers since its discovery by Danish gemologist Inger Lindman in 1936, and how it moves, its rotation speed and direction has been at the center of a decades-long debate. A growing body of evidence suggests the core's spin has changed dramatically in recent years, but scientists have remained divided over what exactly is happening and what it means. Part of the trouble is that the Earth's deep interior is impossible to observe or sample directly. Astronomers have gained information about the inner core's motion by examining how waves from large earthquakes that ping this area behave. Variations between waves of similar strengths that passed through the core at different times enabled scientists to measure changes in the inner core's position and calculate its spin. Definitive rotation of the inner core was proposed as a phenomenon in the 1970s and 80s, but it wasn't until the 90s that astronomers' evidence was published, says Dr. Lauren Rosinski, a senior lecturer of physical science at James Cook University in Australia. But researchers argued over how to interpret these findings, primarily due to the challenge of making detailed observations of the inner core due to its remoteness and limited available data, Linsky said. As a result, studies which followed over the next years and decades disagree on the rate of rotation and also its direction with respect to the mantle. She added, some analysis even proposed that the core didn't rotate at all. One promising model proposed in 2023 described an inner core that in the past had spun faster than Earth itself, but was now spinning slower. For a while, the scientists reported the core's rotation matched Earth's spin. Then it slowed even more until the core was moving backward relative to the fluid layers around it. At the time, some experts cautioned that more data was needed to bolster this conclusion. And now another team of scientists has delivered compelling new evidence for this hypothesis about the inner core's rotation rate. Research published June 12th in the journal Nature not only confirms the core slowdown, it supports the 2023 proposal that this core declaration is part of a decades-long pattern of slowing down and speeding up. The new findings also confirm that the changes in rotation speed follow a 70-year cycle, said study co-author Dr. John Vidal, Dean's Professor of Earth Science at the University of Southern California's Jones Life College of Letters, Arts, and Sciences. We've been arguing about this for 20 years, and I think this nails it, Vidal said. I think we've ended the debate on whether the inner core moves and what's been its pattern for the last couple of decades. But now all are convinced that the matter is settled, and how a slowdown of the inner core might affect our planet is still an open question. Though some experts say Earth's magnetic field could come into play. Magnetic attraction, buried about 3,220 miles deep inside Earth, the solid metal inner core is surrounded by a liquid metal outer core. The inner core is made mostly of iron and nickel, and it is estimated to be as hot as the surface of the sun, about 9,800 degrees Fahrenheit, 5,400 degrees Celsius. Earth's magnetic field yanks at this solid ball of hot matter, making it spin at the same time. The gravity and flow of the fluid outer core and mantle drag at the core. Over many decades, the push and pull of these forces caused variations in the core's rotational speed, Vandal said. The sloshing of metal-rich fluid in the outer core generates electrical currents that power Earth's magnetic field, which protects our planet from deadly solar radiation. Through the inner core's direct influence on the magnetic field is unknown, scientists had previously reported in 2023 that a slower spinning core could potentially affect it and also functionally shorten the length of a day. When scientists attempt to see all the way through the planet, they are generally tracking two types of seismic waves: pressure waves or P waves, and shear waves or S waves. P waves move through all types of matter. S waves only move through solids or extremely vigorous liquids, according to the U.S. Geological Survey. Geologists noted that in the 1880s, that S waves generated by earthquakes didn't pass all the way through Earth. And so they concluded that Earth's core was molten. But some P waves, after passing through Earth's core, emerged in unexpected places, a shadow zone, as Layman called it, creating anomalies that were impossible to explain. Layman was the first to suggest that wayward P waves might be interacting with a solid inner core within the liquid outer core based on data from a massive earthquake in New Zealand in 1929. By tracking systematic waves from earthquakes that have passed through the Earth's inner core along similar paths since 1964, the authors of the 2023 study found that the spin followed a 70-year cycle. By the 1970s, the inner core was spinning a little faster than the planet. It slowed around 2008, and from 2008 to 2023 began moving slightly in reverse relative to the mantle. Thank you for watching this video, and peace out till the next one.